All right, this is for algebra. New chapter, new color. We have yellow notes for Unit 2 for algebra. And so this is 2-1, functions. Now, functions are a big part of algebra. So this first section, we will be teaching over 2 days. And then we will actually also have a function activity on Wednesday. So you know it's a really big deal when I split up one section over 3 days. So it's important. So the state is going to expect you to know some vocabulary. All right. First thing it's going to expect you to know the difference between a domain and a range. Okay. So your domain, this is your set of inputs. These are your input numbers, or all of your x values. Okay. And then your range, this is your set of outputs, or all of your y's. So you can think of a function as a machine. Okay. Not very good at drawing it, but there we go. All right. So this is your function machine. Okay. So you put x's in. All right. You put x's in, and those are your domains, okay? And then it does some sort of function. Here's your math. Your math magically happens in here, okay? And then it spits out your output or your y. The x's go in, do the math, the y comes out. All right, so a relation. Relations, that is your pairing of your domain. Sorry. Trying to get it. There we go. Domain and range. All right. And then what is a function? All right. The function, because I do apologize, I didn't have the question, the part on the left that I normally do. So what is a function? That is the main question. What is a function? That should be the question that is over here in the left-hand column. So a function, it is a relation with exactly one output for each input. Okay, in other words, all of your x's must be different. Okay, so what we're looking at today are our x's, or inputs, or the domain. Okay, they all have to be different. So let's look at that in a couple of different formats. Okay, first we are going to look at it in mapping. All right, we have the domain here. We have our range. Domain is your x, range is your y, and our domain is -4, -2, 2, 5. Each of these only have one line coming from them. Each of them is different. Because each of them is different, there is only one element. So we each have one domain, has one range. Domain, range, domain, range, domain, range. So each of them has one line coming from them. So the mapping is a function, okay? When we have a table, the domain or your x's are always on top. Or if the table is vertical, your x's are always first. Okay? So we have our domain and our range. Always look at your x's. 2, 6, 8, 2. Okay, I repeated 2 twice. So the element 2 in the domain is paired with both 3 and -3. In the range. So this relation is not a function. Now, sometimes you get them in ordered pairs. Okay, x, the ordered pairs is always xy. We're looking at our x's. We've got 2, 4, 8, 4. What number did I repeat? Well, I repeated 4. So the element 4 in the domain pairs with both 7 and 13 in the range. So this relation is not a function. Okay. Remember your summary. Tomorrow or the next day, when you're done with your notes, come back, look at it, write out one of the most important things you learned. You know, summarize your notes as a whole, whatever you need to do here, because I'll be looking for them at the end of the chapter. All right, so your I can statement for this section. I can recognize if a relation is a function. Okay, so on the back, let's analyze some data, and then let's talk about graphs and equations for a couple minutes. Okay, so analyzing data. So 5 schools are competing in a long jump portion of track meet. The distance of the players with the best jump on each team are as follows, and it gives you a list. Well, all those numbers kind of float together. Then it gives you a picture, and all the numbers, you know, there's kind of jumbled and out of order based on, you know, who jumped the furthest. So sometimes we like to have a table just to clean up the data and make it easier to view and process mentally. So let's do that. Let's fill in our chart. So they already did team 1 for us. So team 2. Team 2 is right here. 21.5. Team 3. 20.9. Team 4. 19.4. And then finally team 5. 20.2. Now sometimes you will be asked to list out your domain and your range. And that's just an individual list of your x's and then an individual list of your y's. So instead of ordered pairs, we're tearing the ordered pairs apart. All right, so my domain in this case, it's all of my x's, which is the top of my table. So my domain. 1 through 5. 1, 2, 3, 4, 5. My range is all my y's. 20.6, 21.5, 20.9, 19.4, and 20.2. All right. Now it says determine whether the relation is a function. Well, all my x's are different, so yeah. For each element in the domain, there is one element in the range, so this relation is a function. All right. I think you're getting the idea. Now, when we look at graphs, okay, when we look at graphs or we look at equations, when you have a graph itself, you have what we call a vertical test. Take pen and pencil, put it vertically along the graph lines, and how many times does your pen or pencil cross the graphed line? Well, this is a straight line, and so my pen crosses the graphed line only once. Okay, so remember these are my x-axis, so it only crosses any particular x once. Okay, so this is a function. But how can we tell if an equation is a function? Okay, there are two main equations that we're going to focus on. Okay, we're going to look at the standard, which is what this is written in, the standard equation. We have standard form, and then we have slope-intercept form. Now these two forms of equations are interrelated, and we're going to go into them in much more depth later in the year. So standard form, slope-intercept form. Standard form is ax plus by equals c, such that a, b, and c are all integers, which just means they're numbers. But if you notice, the one thing missing, none of these have exponents. No exponents. Okay? Slope-intercept form, y equals mx plus b. This is also called the equation of a line. Also notice, no exponents. No exponents. So you may get an equation that's not in this format, but you could rearrange it to be in one of these two formats that are related to each other. And when you math out the equation, you could start with exponents, but you could math them out. And if they get mathed out, then you may be left with one of these forms of this equation, because these are interrelated, and we can go back and forth between these two. And so if they are in this form, ax plus by equals c, which is what this one is, or y equals mx plus b, or you can math them to get to look like one of these. Remember, no exponents. Then your equation is a function. But be very mindful. If you have exponents, check to see if you can math them out first. Because if you can math them out, it could still be a function. All right, you have an assignment. On your assignment, on the piece of paper to show your work, you are literally just, I think there's 13 of them, right? Because on the assignment, you have to say yes or no, and there are 2 reasons why. You have to pick the reason why. But on your paper to turn in, I just want you to write whether it's a function or not a function. 2 options, function or not a function. All right, you got this. Good luck.